Okay, hello everyone. Assalamualaikum warahmatullahi wabarakatuh. And very good day to all of you. Okay, so my name is Nur Najahatul Huda binti Saris. Okay, you can call me Dr. Najah. Okay, I'm from University Technology Malaysia Kuala Lumpur. So today I would like to do some discussion, to do some explanation on the example of the DC analysis of the E-MOSFET. Okay, when we talk about the E-MOSFET, it is very important for you to know. In order to analyze the E-MOSFET circuit, there are two types of analysis. The first one is the DC analysis, the direct current analysis, and the second one is the alternating current analysis. So today, let's take a look at the example of the DC analysis of the E-MOSFET. All right. In this topic, when we want to discuss about the E-MOSFET of the electronic devices, okay, we have to fulfill two important course learning outcomes. Okay, which are the first one, apply the basic law and theorems of the electronic device. Okay, for this case is the E-MOSFET to describe the basic operation. Okay, so whenever you want to do this example, it is very important for you to know the basic law and the theorem of the E-MOSFET. Okay, and then the second one is apply the basic law, theorems, and method of analysis to solve the complex problem related to the circuitry. As I mentioned before, it is very important to know how to analyze the E-MOSFET circuit analysis in two types of analysis. Which are the first one is the AC analysis, okay, or the DC analysis, and the other one is the DC analysis. Okay, so I would like to remind you, okay, in this video we will do the example for solving the DC analysis of the E-MOSFET. Okay, and the third one, work in a team and communicate effectively. Okay, so I would like to recommend to you to work in group. Okay, so that you can understand the example that we are going to discuss in this video. Okay, okay, let's take a look here. Okay, let's see. Okay, so here I will give you two kind of sample, okay, of the E-MOSFET DC analysis so that you can relate if the question give you a different version of the question. Okay, so the question will ask you, okay, maybe, okay, at first maybe the question, as you can see here, okay, it is the typical voltage divider of the E-MOSFET. So now, when we want to do the DC analysis, okay, it is very important for us to follow the steps that have been outlined in the lecture notes lah. Okay, so okay, at first let's take a look at the question. Okay, so for the biasing circuit showed, okay, calculate the IDQ, the VGSQ, VDSQ, VD, and also the VS. Okay, so now, okay, so when you look at the circuit, we know that the circuit is the voltage divider biasing of the DC analysis of the E-MOSFET. So what you have to do is that, okay, whether it is the BJT curve or whether it is the E-MOSFET curve, it is very important for you to simplify, okay, to draw the DC equivalent circuit of the E-MOSFET. Okay, kalau BJT tu you have to draw the BJT lah. But then if the question is the E-MOSFET, so you have to draw the E-MOSFET DC equivalent circuit, okay, of the voltage divider. Okay, so now, okay, as you can see here, okay, the VDD is, okay, so as you can see here, okay, the VDD is 40 volt. And then you have the gate, you have the drain, you have the source. And these are some of the information that you have to extract from the question, meaning that you have to identify some of the parameter that have been given in the question. Okay, for example, the VGS threshold, the threshold of the GS channel. And then the second one, okay, as you can see here, the drain current, okay, at on condition, which is 3 milliampere. And then the VGS at on condition is 10 volt. Okay, so in order for you to answer this question, okay, it is very important for you to remember this formula in which, okay, in which, okay, for example, here we have the formula of ID equal to K, okay, the VGS minus VGS TH, okay, the threshold of the GS, okay. And then whenever you want to find the value of the K, for example, in this question there is no K, so what you have to do by using this formula, okay, you rearrange, but the value of ID you have to put at on condition, okay, over VGS at on condition minus the VGS of the threshold value squared. Okay, so now you can find the value of the K. Okay, so this one is very simple step. Okay, it's very similar. At first, you have to identify, is there any capacitor? No capacitor. Okay, so with no capacitor, just ignore lah. And then the second one, you have to extract all the information from the question or from the circuit. Okay, for example, the value of K, the value of the VGSTH, okay, the threshold value of the gate to source voltage, okay. And then other than that, okay, what else? Okay, the VTH if the question is related to the voltage divider lah, okay, and also the RTH and so on, okay. And then after that, okay, you have the choice whether you want to draw the simplified circuit, okay, the simplified circuit, or you can plot, okay, the circuit, okay, plot the graph lah, okay, plot the graph, you have the choice. Okay, so at first here, okay, after this I will show you how to solve this question. Okay, this one is just a revision for you so that you can understand, you can remember how to solve this kind of question, especially for the voltage divider. Okay, voltage divider. So the question, we focus on the IDQ VGSQ, meaning that what you have to do, you have to plot the graph. Okay, plot the graph to find the Q points. Okay, so the Q point is the VGS IDSQ. Okay, in which the IDQ is the output of the circuit and VGSQ, okay, VGS especially is the input parameter. Okay, input parameter. Okay, so now let's take a look, okay, the next slide. Okay, so how to solve this? At first, okay, analyze the circuit. Okay, is there any capacitor in the circuit? No. If there is no capacitor, just ignore. Just move to the next step. But if there is a capacitor, what you have to do is you have to remove the capacitor. You have to make the capacitor as an open circuit. Okay, because this is the DC analysis. That is why we want to remove the capacitor. We want to exclude the appearance of the capacitor. Okay, we don't want the capacitor because in the E-MOSFET, okay, the function of the capacitor is want to be the bypass capacitor or the coupling capacitor. Okay, to couple between the signal of the DC and analysis. Okay, DC and AC analysis. But in DC analysis, we only consider the DC signal. Okay, so next, okay, extract and identify the information from the question circuit given. Okay, the question or the circuit given. So as you can see here, the value of the VGS at the threshold value in which, okay, when the voltage supply exceed this value, so the MOSFET can be function, can be switched on. Okay, that is the meaning of the threshold value of the VGS. Okay, then what are the other information that we can get from the circuit is the value of the K. Is there any value of the K? Okay, if you don't have any value of the K, but since you have the ID on, okay, the VGS on, okay, and also the VGSTH, okay, so you can calculate by using the formula. For example, this one, okay, the formula this one. Okay, so as I mentioned earlier, in order for you to calculate, okay, to calculate the value of the K, so it is very important for you to draw, to write, okay, to use the formula that is uh, related to the on condition. ID on equal to K VGS on, okay, minus with the VGS TH, the threshold value of the GS, okay, voltage and square. Then you rearrange this formula and you can get the value of the K. Okay, it is very straightforward, only by using one formula. Only by using one formula, one equation, you can get the value of the K. Alright, so next, find the values in B if it is not given. Okay, so as I mentioned, the value of the K, okay, the value of the VGS and so on. But most of the time, okay, the most important parameter that we want to determine is the K value. Okay, the K value, if the K value is given or if you can calculate the K value, so it is easier for you to proceed with the other solution. Okay, to do the to provide the solution. It is very simple. Okay, next D, simplify the circuit since this is voltage divider. E-MOSFET biasing circuit. Okay, and then find the RTH and VTH. So remember lah, okay, so from this one, okay, let's say, okay, we put this as R1. Okay, usually we put this one as a R2. Okay, so by using the R1 and R2, you can get the RTH, the Thevenin resistor. Okay, in which you have to do the parallel lah. Okay, R1 parallel with the R2. Next, what else? What we can do is, in order to simplify the circuit, you can find the value of the the Thevenin voltage. Okay, so how to find the value of the Thevenin voltage? Okay, the Thevenin voltage, remember, this one is not the threshold. This one is the Thevenin voltage. Okay, this Thevenin voltage is equivalent to the voltage across the gate here. Okay, VG or VTH. Sama. It is the same. Okay, VG ke, VTH ke, it is the same. It is equivalent. Okay, the V Thevenin, okay, which is the Thevenin voltage, is equal to the voltage at the gate terminal. Okay, so remember. So what you have to do, you have to find the value of the RTH and you have to find the value MVTH. Then you can draw the equivalent circuit. Okay, for example, this one is the VTH. Okay, this one is the RTH. Then you can draw lah. Okay, the MOSFET. Okay, and the VDD. This one is the RD. This one is RE. RS. Sorry. RS. Okay. So, it is simple. Okay. So, plot the graph using the formula ID equal to K VGS minus VGS TH squared. So, it is the same. Okay. The same that you want. Okay. The same that you use. Okay. In order to find the value of the K. Okay. But, for this case, it is not the ID on. Okay, this one is the ID at the Q point. Okay, in order to find the value of the, in order to plot, okay, the transfer characteristic, the transfer characteristic curve. Okay, so, and then in order for you to plot the graph, it is very important for you to construct the table. Okay, the VGS and the ID. Okay, okay, and finally analyze the GS loop. Okay, this one is the GS loop. Okay, this one is GS loop. This one is the D to S loop. Okay, so from the GS loop, you may find the DC load line. Okay, you can find the DC load line, the intersection of the x-axis and also the y-axis. Okay, now, next. Okay, this is the way how to solve this circuit. Okay, for example, at first we calculate the value of the K by using the ID on equal to K, okay, VGS on. Okay, VGS on. This one is the VGS on. Okay, so VGS on. VGS on. This one also VGS on. Okay, so next. Okay, then you insert the value ID on, VGS, VGS, TH, and then you can get the value of the K. So don't forget to put the unit, okay, whether it is milliampere over V squared, okay, or microampere. It depends on the calculation. It's very important for you to put the unit. Okay, next, okay, you have to draw the simplified circuit, meaning that you have to draw to change this parallel of the R1 and also R2 to be the Thevenin resistor. Okay, to be the Thevenin resistor. Okay, so as you can see here, how to calculate the voltage Thevenin, okay, which is equivalent to the VG, okay, the R2, okay, this one, the R2, okay, times with the VDD, the source of the voltage, okay, divided by R1 plus with the R2. Then you can get the value. Do the calculation and then you can get the value. Okay. Meanwhile, to calculate the value of the Thevenin resistance, okay, so R1 parallel with the R2. Okay. So this one lah. Okay. Then what you have to do is by using this formula, okay, by using this equation, you just insert the value. Just now we have calculated the value of the K, right? Okay, so this one is 0.12 milli. Okay, and the VGS, we don't know the value of the VGS. We don't even know the curve of the circuit. Okay, the transfer curve, you don't know. So what you have to do is you just need to assume the value, and then from the assumption you calculate to get the value of the ID. Okay, then you can plot the graph. You can plot the graph. Okay, but at this point we don't even know the Q point yet until we draw the load line. Okay, the intersection between the load line and also the transfer curve is indicate the value of the Q point. Okay, alright. So at here, okay, you just need to plot. Okay, so after that, what you have to do is you have to analyze the GS loop and also the DS loop. Okay, the GS loop and the DS loop. Okay, so this one is the GS loop. This one is the DS loop. Okay, let me draw for you. Okay, so this one, because of this one is the D, S and G, so this one is the DS loop. Okay, so this one is the GS loop. Okay, so you don't forget to include the VGS. Okay, this one is the VTH, which is equivalent to the VG. Okay, sama. Alright, so next, okay, so now, okay, we analyze the GS loop. Okay, the GS loop, for example, 18 minus with the, this one is IG, alright? IG RTH. Okay, IG that across this resistor. Okay, then minus with the VGS. Don't ever forget to put the VGS. It is very important. You don't need to ignore. You have to include the VGS in your calculation. Even though it is not stated here, but you have to put it. Okay, so now, okay, the loop is continue with the ID times with the RS. Okay, so in the GS loop, okay, which is the input loop, it is very important for you to remember that the value of the IG will always to be 0. Okay, because that is the theory, okay, the theoretical value for the FET, which is the IG will always 0. Okay, the IG will always 0. So when the IG is 0, so automatically this one will be 0. Okay, so VG or VTH is the same lah, kan? It is equivalent to the VTH. VTH ke VG, it is equivalent. Minus with VGS. Okay, VGS minus with the ID RS. Okay, so since this is the series circuit, why we consider the ID, not we consider as the IS? Because this is the KVL, okay, the series of the circuit. The series of the current means the current of the ID and IS is the same. Okay, so now you insert, okay, the VGS equal to VG minus ID RS. So remember, whenever you want to draw the load line, always refer the GS loop to indicate the load line. Okay, from the formula at the GS loop. Okay, so VGS equal to VG, or you can put VTH, okay, minus IDRS. Okay, so VTH, we already have the value of the VTH, okay, the one that you calculated just now. Okay, R2 divided by R1 plus with the R2 times with the VDD is equal to the VTH. Okay, so now to find the load line, you have to assume when, for example, at the y-axis, okay, when the ID is 0, so meaning that the VGS is equal to the Thevenin voltage. Okay, what is the value of the Thevenin voltage just now? Is the 18. So meaning that here is 18 volt when ID equal to 0. Then here we know that the formula VGS equal to VTH minus ID RS. So here, when we want to find this y-axis, okay, so you have to let the value of the VGS is equal to 0. Okay, so VTH equal to IDRS. Okay, so ID equal to VTH divided by RS. Okay, so VTH is 18. The RS is, what is the value of RS? RS is 0.82. Then you can get this one. Okay. Alright. Then what you have to do is, okay, just now you have plot the transfer characteristic curve, right? And then you have the load line. So now you can find the value of the Q point. Okay, the value of the Q point, the intersection, the cross between the transfer curve together with the load line. Okay, that is the Q point. So whenever you want to calculate the VDSQ, okay, nama pun dah VDSQ, meaning that you have to analyze the DS loop using the DS loop. Okay, so remember, whenever you want to solve the DS loop, okay, the value that of the ID, okay, is referring to the IDQ, the one that you get from the one that you have calculated, the one that you have identified from the graph. Okay, the IDQ. Okay, so the IDQ. So from here we know that VDD minus with the current that is flow through this across this resistor is the ID. Okay, wait a minute. Let me draw for you. This one is the ID. So ID times with the RD. Nampak tak? Okay, ID times with the RD. And then minus with the VDS because of this one. The current flow through this channel. Okay, the current flow through this channel. So you have to minus with the VDS. Minus with the ID. Okay, this one because of the series. So we assume the current that flow through across this resistor is the ID. Okay, because ID is IS. Sama. Okay. So next equal to 0. Equal to 0 lah. Okay. Equal to 0. Alright. So then you can solve by inserting the value of the ID that you found from this Q point and also the this one IDQ lah. Then you can rearrange, solve, then finally you can get the value of the VDSQ. Okay, settled. Alright. So this one done, and done. Okay, the calculate the value of the VDS, okay, meaning that VD, meaning that you want to calculate this at this point, the VD, and then the S, the voltage at the gate, at the source, not the gate. Okay, the VS. Okay, so as you can see here, VD equal to VDD minus IDRD. Okay, so this one, okay, technically on how you solve the voltage divider, especially related to the MOSFET for the DC analysis. Okay, the DC analysis. Next, I will show you, okay, with some sort of different presentation of question. Okay, different type of the question, but okay, means that the question can be manipulated, okay, in very different ways lah, in many ways. Okay, sometimes the question can give you this straight line, this straight to the point question. Okay, meaning that you have the value of the VDD, okay, you have the value of the R1, R2, okay, and then you have the value of the RD, you have the value of the RS. But sometimes the question will try to give you excitement, okay, kan, kejutan, surprise, okay, in which they will not give you the value of this resistor. Okay, you have to find the value of the resistor, each resistor's value. Okay, maybe this question will give you the value of the VDS. Then you have to find this resistor. Okay, you have to calculate. Okay, you have to identify how to analyze the graph. From the graph, you have to know how to extract the information. Okay. All right. So let's take a look. All right. So as you can see here, okay, we have the same circuit, okay, the similar circuit. All right, but You don't have any value of R2, you don't have any value of the RD, and you don't have any value of the RS, but given to you the graph, the transfer curve graph. Okay, so before going through each question, I just want to analyze together with you how to interpret the data, how to extract the data from the graph. Okay, all right. So we know that this one is the formula to draw the transfer curve, right? Transfer curve. curve. All right. So from here, we know that this value we will get when the ID is equal to 0. All right. Okay. So this one is the Q point in which, okay, I dq, no, VGS, okay, let me make correction, okay, in which the VGSQ and x-axis, y-axis is the IDQ. Meaning that from here, we know that the value IDQ, okay, we know that the value is VGSQ. And this one is the IDQ, right? So we have found the value of the VGSQ lah, especially. Okay, so from here, we know that this one is the VGS threshold value. Because from the circuit, you are not given the information direct to the point, straight to the point. Okay, usually the question will give you the value VGSTH is equal to blah, 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 blah. But now, from the graph, you have to extract the information. You have to gather all the information given, okay, from the graph. Okay, so from the graph, you know that the VGSTH is equal to 5 volt. Here, the VGSQ is equal to 12.5 volt. Okay, so now let's proceed. Okay, moving on, the first question, determine the value of the VGSQ and IDSQ. IDSQ. Okay, but now, okay, from the graph, we know that the VGSQ is 12.5 volt. Okay, you can simply take from the graph, easily get the answer. And then, what about the IDSQ? How? Okay, so remember, as I mentioned, whenever um, we try to solve any question that is the Q point, okay, that is indicate the Q, okay, meaning that you have to get from the points, right, from the Q points. But now let's do how we can get the value of the IDSQ given, okay, when you have the information about the VGSQ. Okay, so now, okay, from the graph, we can identify the value of the VGSQ, okay, which is 12.5 volt. Okay, to find the value of the IDQ, okay, we will use the formula IDQ equal to K VGSQ minus VGSTH squared. Okay, so remember just now, okay, you use this formula in order to plot the graph. But now, the true value, the original value of the Q point has been given. So how, from the value, you can manipulate the equation so that you can get the IDQ. Okay, so at first, what you have to do is you have to find the value of the K. Otherwise, we don't know. We cannot solve the IDQ. So, using the ID on, okay, ID on, okay, VGS on, you can get the value of the K. ID on has been given 12, 3 milliampere. Not 12 lah, kan salah. 3 milliampere. Now VGS on has been given in the question, 10 volt. Okay, 10 volt. Then VGSTH, you can extract from the information, you can extract the information from the graph, okay, which is at the point where the MOSFET is activated. Okay, this is the switch, macam switch lah, okay, the starting point. Okay, so you just solve this question. Then you calculate, you can get the value of 0.12 milliampere. So technically, it is just the reverse from the previous question. Okay, the previous question, okay, you have the value of the R2, RS, and RD. Okay, you have given the VGSTH, but now in order for you to get the value of the VGSTH, you have to find and determine from the graph. Okay, we want to know how understand the level of the understanding, the concept that you learn from the class. Okay, and then, okay, so you have calculated the value of the K. Okay, and then VGSQ already found in the graph. So VGSTH, okay, already, okay, together. Then you insert the value. Then you can, K is 0.12 milliampere, okay, over V squared, alright. And then times with the VGSQ, which is 12.5, minus with the 5 volt, okay, which is the VGSTH. Okay, so you can get the value of 6.75 milliampere. Alright. Alright. So next, to play safe, what you have to do whenever you found the voltage divider, you just can draw straight away the simplified version of the circuit, the DC equivalent circuit of the voltage divider, so that you can analyze the GS loop, the DS loop easily. Okay, so remember lah the formula of the Thevenin voltage, okay, which is equivalent to the V gate, okay, the gate voltage, which is R2, okay, divided by R1 over, okay, R2 divided by R1 plus R2 times with the VDD, which is 40. Okay, but this one, you just keep first, okay, because we will try to use this idea, okay, to solve the next question. Okay, the next question is calculate the resistance values, okay, of the RD, of the RS, RD, and R2. If the value of the VDSQ is 14.06. Okay, so now that is why I asked you to draw the simplified circuit so that it is easily for you to analyze the GS loop, okay, to find any parameters, okay, the required parameters, for example, the RS, RD, and also the R2. Okay, so how to find the RS? Okay, in order to find the RS, you have to solve the GS loop. Okay, you have to solve the GS loop. Alright, so how? Okay, we know that, okay, from the loop VTH minus with the IG, right? Okay, the current that flow across this one is the I gate, IG, this one. The current that flow across this RS is IS. But since this is the series circuit, okay, so we will assume that IS is equivalent to the ID. Okay, never mind. Okay, so for the KVL of the GS loop, okay, the VTH minus IGRTH minus VGS, okay, minus with the IDRS equal to 0. This one. Alright. So, when IG is equal to 0, so you can rearrange the VTH minus VGS minus IDRS equal to 0. And then the VGS equal to this one. Okay, now we want to know the value of the VTH because from the simplified circuit we cannot calculate the VTH because we don't know the value of the R2 and also the this one, right? The RTH, VTH, we don't even know the value. So now when the ID, okay, from here, okay, so from the load line we know that, okay, remember, in order for you to draw the load line, okay, you have to analyze the GS loop. In other words, from the GS loop, okay, you can get the information to draw the load line. That is why, okay, in order for you to find the value of the VTH, we will analyze the GS loop. Okay, GS loop. Okay, so now, okay, from this formula, when, okay, this one, right? Okay, when the ID at this point, okay, the ID is 0 at this point because there is no intersection between the y-axis. So at this point, only the VGS value that we can calculate, we can identify. Okay, the ID equal to 0. When the ID is equal to 0, meaning that the value of the VGS is equal to VTH. Or we can say that the value of the VTH is the value of the VGS. Okay, so this one is the VGS. Okay, this one is the VGS. Alright, VGS kan? Okay, so VTH is equal to 18. Alright. Okay, using the formula of the VGS again, okay, now we already have the value of the VTH. So, we just insert, okay, the VTH is 18, okay, GS loop. So, meaning that whenever you want to find the value of the RS, okay, any parameter of the circuit, you have to use the VGSQ. VGSQ. Just now, we want to draw the load line. The load line. Identify the VTH from the load line. That is why, okay, we assume that the VTH is equal to VGS. VGS, this one, intersection. Okay, but now is the formula to find the parameter, the required parameter in the formula of the GS loop. Okay, so 18 minus with VGSQ divided by IDQ. Okay, and then you can get the 0.81 kilo ohm. Okay, 0.82 pun sama lah. Kalau previous question, 0.82 kilo ohm. So, it is approximate lah. Okay, sama, dekat nak sama. Okay, dan from, we have calculated the RS. Now, we want to calculate the value of the RD. RD, kat sini RD. So, if we want to calculate the value of RD, meaning that we have to use the DS loop. Right. Okay, the DS loop. So, VDD, okay, VDD minus, this one is ID. Okay, the current. ID times RD. Okay, minus with the VDS. Okay, this one. Okay, the VDS. Then minus with the ID RD. ID RD. Kenapa kita tak gunakan IS? Sebab we assume that the IS is equivalent to the RD. ID. Okay, IS is equivalent ID. Okay, that's why we use the ID. Okay, this is a series. Alright. So now, okay, you insert the value. This one is the IDQ, IDQ, okay, RD minus 14, which is VDS, given the value of the VDSQ, minus IDQ, okay, and then insert the value of RD. RD ke? RS ni. Sekejap. Sekejap this one correction. Nah, RS. So RS dah dapat. RS. Okay, then you just insert and you can calculate. Finally, you get the value of 3.01K lah. But here I just put 3K. Okay, so then next calculate the value of the R2 using the original circuit. Okay, so in order for you to draw, to find the value of R2, okay, we must relate to the RTH ataupun VTH, right? Sebab we need to relate with the R1 as well. Okay, R1. So now, okay, calculate the R2 using the original circuit. Okay, from the VG lah kat sini. Okay, so kita tahu, we know that, okay, the R2, okay, this one. Okay, we don't know the value of the RTH. That is why we didn't use the formula of R1 parallel with R2. But we have the information about the VDD, okay, the R2, and also the VTH. That is why, in order for you to find the value of R2, you use the VTH equivalent R2, R1 plus with the R2 times with the VDD. Okay, insert the value and then you can find the value of the R2. Okay, so as you can see here, okay, there are a variety of question that that can be orang kata apa, came out in the final exam. But if you do understand the concept, okay, putar balik macam mana sekalipun lah, you can answer. Okay, it is very important for you not to memorize but understand the concept. Otherwise, if you don't understand but you memorize, you cannot kata apa? You cannot perform lah in the exam. Okay, you cannot implement in the exam. Okay, so that is why during my time I love to understand the concept rather than memorize the answer lah kan, the question. I don't usually memorize lah. It is more towards understand the concept of the question. Okay, so at least what you have to do is you have to know how to draw the graph. You have to know how to extract the information from the graph. Okay, you have to understand how to solve. Okay, how to simplify the circuit, especially the voltage divider. Okay, next. Alright, as for the conclusion, I would say that the example of the DC circuit analysis of the E-MOSFET have been discussed previously in this video. So what I want to highlight here is that you have to know how to simplify the circuit whenever we deal with the E-MOSFET of the DC circuit analysis. And then what you have to know is you have to know how to plot the graph by using the formula of the current. And then after that, what you have to know is you have to analyze the GS and the DS loop in order to find the DC loop line. Okay, and then I think, okay, I wish you all the best. Okay, I hope that this video can help you, okay, to enhance your understanding in the E-MOSFET of the DC circuit analysis. Okay, with that, thank you and Assalamualaikum warahmatullahi wabarakatuh.